In this video, we're going to be talking about linear simultaneous equations. Now, simultaneous equations have a number of real-world applications. For example, an air traffic controller could use simultaneous equations to ensure two aeroplanes don't intersect at a given time, causing a fatal collision. Now, by the end of this video, you should be able to understand what is meant by a linear simultaneous equation, solve simultaneous equations by elimination, and solve simultaneous equations by substitution. So the first question is, what is a linear simultaneous equation? Now, by now we should be pretty confident in understanding what is meant by a linear equation. So a linear equation is simply an equation for a straight line, okay? So that would often be in the form of y equals mx plus c. And it involves no terms such as x squared, y squared, or any higher powers. Now, a linear simultaneous equation is where we take two of these linear equations and we try to find the point that those two straight lines intersect, okay? So at that point there. Now, at this point of intersection, both equations are satisfied at the same time. In other words, linear simultaneous equations will have one set of values that will make a pair of equations true at the same time. So for example, let's say we had the equations x plus 3y equals 11 and 4x minus 5y equals 10. Okay, so here we have two linear equations. Now we know that the solution to this pair of equations is going to be x equals 5 and y equals 2, because at this point both equations are true at the same time. So x plus 3y would become x being 5 plus 3 times 2 is 6, which is equal to 11. Okay, true. And then we've got 4x minus 5y. So 4 times x is going to be 20. Okay. And then we got minus 5y. So minus 5 times 2 is 10. And that is equal to 10, which is also true. So how about solving simultaneous equations? Now, when we talk about solving simultaneous equations, this involves taking two linear equations, like we have here, and finding the x and y values that satisfy both equations. So here, in this example, I gave you the answer what x and y were to prove that, these are true. But how can we take these two equations here to find x and y? That's what we're doing when we're solving simultaneous equations. Now, linear simultaneous equations like these two can be solved using a process of elimination or substitution. And we're going to look at both of these in turn. So let's look at elimination first. Now, the best way to see how this works is to have a look at an example. So let's solve the following linear simultaneous equation by elimination. So let's say we have 2x plus 3y equals 8, okay? And we've got 3x, oh, that's a y, 3x minus y equals 23, okay? And we're going to label this our first one, and this is our second one. So our first linear equation and our second linear equation. And so essentially what we're looking to do, we're looking for a way to eliminate x or y. Okay, and we do this by first getting either both of the x terms or both of the y terms the same, okay? And it doesn't matter if one is negative and the other is positive. For example, 4x and minus 4x. What we're interested in is having this number before the x or y the same, okay? Now, in this example, we want to multiply this second equation here at the bottom by 3, okay? So that way we're going to have 3y in both equations. So let's do that now. If we do 3x times 3, that's going to give us 9x, okay? And let's say then we got negative y, we're going to multiply that by 3 as well. Just so we know what we're doing, multiplying that by 3. 9x minus 3y equals 23 times 3 equals 69, okay? And that is we're going to label that with a number 3, okay? Now, as you can see, now we have positive 3y in equation 1, and we have negative 3y in equation 3. So if we add those two equations together, so we want to add these ones together, we will eliminate the y terms, okay? Because positive 3y minus negative or plus minus 3y will give us 0, okay? So the y terms are deleted, okay? Now, if the terms had the same symbol, so that was positive 3y and that was positive 3y, or that was negative 3y and that's negative 3y, then we would have to subtract the two equations to eliminate the y terms. But as these symbols are different, we're going to add to eliminate the y terms. So 2x plus 3y equals 8 plus 9x minus 3y equals 69 will give us the following. And we're going to do this in red now. So 9x plus 2x equals 11x. 3y minus 3y equals 0. So I'm going to put plus 0 in there. And finally, 69 plus 8 is going to give us 77. Okay, so we can sort of get rid of this plus 0 because it doesn't really mean anything. So we've got 11x equals 77. And we want to find out what the value of x is, so we simply divide 77 by 11 to get the value of x. And here, x is equal to 7. Now, having found the value of x, we now want to find the value of y. So if we found the value of y first, we now find x, but as we found x first, we want to find the value of y. And we can do this by substituting this value of x here, x equals 7, into equation 1 or 2. Okay, so let's just pick one. Let's say we're going to choose equation 1 and we're going to substitute x equals 7 into this linear equation to find the value of y. Okay, so let's do this over here. Let's say then 2 times x, so 2 times 7 is going to be 14 plus 3y equals 8. Okay, and so very simply now we want to just rearrange the equation so that we get y on its own. So we've got 3y equals 8 minus 14, and 8 minus 14 is negative 6, so 3y equals negative 6, which means that y equals minus 6 divided by 3, which is minus 2. So here's our value of y, here's our value of x. So the solution then is x equals 7 and y equals negative 2. Okay, and finally we're going to do solve a simultaneous equation by substitution. Okay, so let's look at another example now. That was the elimination method, and now we're going to look at substitution. So again, the best way to see how this works is to look at a real example. So let's solve the following linear simultaneous equations by substitution. So we're going to have 2x minus y equals 1, and we're going to have 4x plus 2y is equal to negative 30. This is equation 1, this is equation 2. Again, we're looking for a way to get rid of x or y, and we do this by rearranging one of our equations here to get x equals something or y equals something. And in this example, we're going to rearrange equation 1 because this would probably be the easiest given that we've got y by itself already. So we can do this by adding y to both sides and then taking away 1. So it'll be 2x minus 1 equals y, or y equals 2x plus 1. So y equals 2x minus 1. Okay, and so we've now got a value of y here, which we can then substitute into our second equation. So in other words, we can replace y in equation 2 with the value of y we have just found. So let's do that now. We got 4x plus 2. So what's the value of y? We've got y here, 2x minus 1, and that equals negative 30. And we can then simply solve this equation to find the value of x. So we'd have 4x plus 2 times 2x is 4x, 2 times negative 2 is minus 2 equals minus 30. And so 4x plus 4x equals 8x, and minus 30 plus 2 is negative 28, which gives us x equals minus 28 divided by 8, which will give us minus 3.5. Okay, so now we have the value of x. Again, we can substitute this value into equation 1 in order to find the value of y. Okay, so let's do that now. Let's use this one here. It's the same equation. It's just easier to use because we want to find the value of y anyway. So y equals 2 times negative 3.5 minus 1. Okay, and that will give us, if you type that into your calculator, negative 8. So y equals negative 8. Thus, our solution to this simultaneous equation is going to be y equals negative 8 and x equals minus 3.5. So that is the end of this video on linear simultaneous equations. And in the next video, we're going to start looking at quadratic simultaneous equations. So this takes our current knowledge here a little bit further. But if you have any questions at all about this video, then please leave a comment below and I'll get straight back to you. If you enjoyed the video, make sure you give it a thumbs up and subscribe to my channel. Thank you very much for watching.